Thank you for joining today. I know you're all really excited once again to learn about the discriminant. Before we get to that, I just want to give one shameless little plug. Please go ahead and join the boys golf team and you can get some nice free swag. So usually the weather gets kind of cold in March, April, May. So we usually get you guys a nice hoodie. So join the golf team and you get decked out with some pretty sweet clothes. So let's go ahead and learn about the discriminant. We've seen the formula for the discriminant before. It was hidden within our quadratic formula, and that is going to be b squared minus 4ac. So it was all the stuff that was underneath the square root is your discriminant. The first part gives you the vertex. The square root part gives you what's called the discriminant. And the discriminant will tell you how many real solutions there's going to be. And just to illustrate this, let's go ahead and make a sample quadratic formula. We have 3 plus or minus the square root of something over 2. Let's say that something is a positive number. So let's say it was a 16. So if that something was a 16, then the square root of 16 would be a 4. And you'd have 3 plus 4 divided by 2, and you'd have 3 minus 4 divided by 2, which would then lead to 2 different answers. And this is usually going to be the case when you're solving quadratics, is typically it's going to intersect twice and you're going to have 2 solutions. But there's a couple different scenarios that also could happen. If the discriminant is equal to 0, let's see what happens here. If I put in a 0 under there, then what I'm doing is I'm taking 3 plus square root of 0 is 0. So 3 plus 0 divided by 2 and 3 minus 0 divided by 2. And hopefully you realize you're just going to get the exact same answer. So in that case, when the discriminant is equal to 0, you just have one real solution. It's the same answer whether you use the plus or the minus. And if the discriminant is negative, let's try and put a negative 7 in here. If the discriminant is negative, you can't take the square root of that negative number, so it leads to 0 real solutions. I want to give you guys some IB language that sometimes you might see. In the IB world, when you're talking about 2 real solutions, oftentimes they will say that those are called 2 distinct roots. So either 2 distinct roots or 2 distinct solutions. Distinct usually means just different. So 2 different solutions. And this one, sometimes it's a little funny to interpret. When you're talking about one real solution, oftentimes they will call these repeated roots. Repeated means it happened the same thing over again. So sometimes they might call it 2 repeated roots, but if you have 2 repeated roots, it's the same root, which is actually just one solution. So when you see repeated roots, that's a sign that the discriminant is equal to 0. And let's take a look at a couple examples. First one, 2x squared plus 5x minus 1. I just want to find the value of the discriminant and then tell me about the roots of each equation. So first things first, it has to be set equal to 0, which in this case it is. So we are going to take our b squared minus 4ac and substitute the values. So b we replace with 5 squared minus 4 times a times c. 5 squared is just a 25. If we have a negative times a positive times a negative, that's going to be a plus. And 4 times 2 times 1 is an 8. So my discriminant is 33. Since that discriminant is a positive number, I know that there will be 2 real solutions. So for this one, I know the discriminant is positive. Therefore, it leads to 2 real solutions. And let's take a look at what that means in the context of this problem. Let's go to our friend Desmos, and let's take a look at that graph. So we have 2x squared plus 5x minus 1 graphed here. And if you look at it, we were trying to find where it equals 0, and there are 2 spots where that happens. So in this case, there were 2 real solutions. And we'll go ahead and do one other example. X squared plus 10x equals negative 25. First things first, we have to have it equal to 0. So we're going to add 25 to both sides. We get x squared plus 10x plus 25 equals 0. Once it's set equal to 0, we can go ahead and apply the discriminant formula to figure out how many solutions there are. And it would be b squared minus 4 times a times c. 10 squared gives you 100. A negative times a positive is a negative. And 4 times 1 times 25 is 100. So what happens is we have a discriminant that is equal to 0. And if the discriminant is 0, we know that there will just be one real solution. So the discriminant is 0, therefore it leads to one real solution. And if you were to graph this, I won't go over to Desmos, so I'll just sketch it over here. If you were to graph it, it would look something like this. It'd be here at negative 5, way down here at negative 25, and you'd get a quadratic that looks something like this. Here's the line of y equals negative 25, and you'll notice it just intersects that value one time. So in this case, there would be one real solution. So the graph of x squared minus 10x is the parabola that I just drew over here, and we found where it equals negative 25. That's this horizontal line. It will intersect one time. So just one solution. And now I'm going to show you what some IB questions look like for this topic. Find the value or values of k for which this graph has 2 distinct real roots. So the key in here is we're trying to find where it has 2 distinct real roots, which we know means the discriminant is positive. So I'll make a little note there that discriminant is positive. So let's go ahead and find our discriminant. Formula for that is b squared, so that's 9 squared, minus 4 times a, and our c in this case is just k. And because it has to have 2 distinct real roots, it has to be positive. And another way of thinking of positive is it has to be greater than 0. So I'm going to set it as an inequality greater than 0. Then we'll simplify it. So we have 81 minus 4k is bigger than 0. If we add 4k to both sides, we have 81 is greater than 4k. And we can divide both sides by 4, and we get 20.25 is greater than k. Now, typically when I'm interpreting these, I like to read it from the variable where k is less than 20.25. So as long as k is smaller than 20.25, it's going to be 2 distinct real roots. And let's go ahead and take a look at what that one looks like. We had x squared plus 9x plus k, and I have a little slider here for k. You'll notice if k is bigger, so if I pick a number like 24 up here, then there are no roots. You'll notice that it's not intersecting with this x-axis, so there are no x-intercepts in this case. But I make k smaller and smaller and smaller and smaller until if we get to 20.25, oop, I missed. If I get to 20.25, it intersects exactly one time. But as long as k gets smaller than that, now you'll notice that we're intersecting 2 different times. And you can see those intersection points in gray. So as long as k is smaller than 20.25, we have two intersection points. And the second that it gets bigger than 20.25, now there's no intersection points. If we go right at 20.25, there's one intersection point. So we found the range of values, it's all of these over here, where there's going to be two distinct real roots. Let's go ahead and do the next one. Find the value of p such that this equation has two equal roots. So this is another way that they might phrase it. Maybe they phrase it a little differently than we're used to, but if you have two equal roots, that's the same as saying two repeated roots. So if you have two repeated roots, we know that the discriminant is equal to 0. So now we're going to use our discriminant formula, where we have b squared, so your b in this case is negative 2p, and that's going to get squared, minus 4 times a times c. And that discriminant, because there are two equal roots, has to be equal to 0. So it's not an inequality this time. This time we're saying it has to be exactly equal to 0. So we set up an equation. If we take this negative 2p squared, what it really means is negative 2p times negative 2p, and that's going to be 4p squared. And this negative 4 times 2 times 4 is going to be a minus 32, and that should equal 0. I'm going to skip a couple steps here. Hopefully that's okay. I'm going to add 32 to both sides, but then I'm going to divide by 4. So I'm left with p squared is equal to 8. And to solve it, just take the square root. So we get p is equal to plus or minus the square root of 8. So as long as p is positive or negative square root of 8, that's going to lead to that equation having two equal roots. So just one solution. And the last example together. Find the value or values of m such that this equation has no real roots. So if there are no real roots, that means the discriminant has to be a negative number. So we're going to start with our discriminant, b squared, negative 6 squared, minus 4 times a. I'll rewrite that. Our a in this case is 3m, and then our c is 1. And then, because it has to be a negative, so the discriminant has to be a negative, another way of writing that is it has to be less than 0. So I'm going to again set up an inequality where it's less than 0. Negative 6 squared, that's just 36. Negative 4 times 3m times 1 is going to be minus 12m, and that has to be less than 0. And we can add 12m to both sides. We get 36 is less than 12m. Divide by 12 and we get 3 is less than m. So another way of reading this is m is bigger than 3. So the range of values that make it have no real solutions, as long as m is bigger than 3, there won't be any real solutions. So go ahead and try the next 3. Some of these are going to be a little bit more challenging than some of the problems we've been used to, but give it your best shot. If you're stuck, give me an email or we can discuss them in class the next time I see you. So thanks for watching. Have a good rest of the week.